Good morning, sir.
Good morning.
Good morning.
Good morning, sir.
Good morning. Okay. So in this session, we are going to get into the topic is called types of the lattices. Okay. Already you are discussed the definition of the lattice. So there you are supposed to be provided one poset with respect to the relation in which if it has the GLB and then LUB for each and every pair of the vertices which belongs to the set, then the given set with respect to the relation is called not only poset, it is also to be called as a lattices. So we had solved sufficient examples in that lattices by providing the set with respect to the relation. We have checked all the pairs LUB and then GLB. If it has means then we are confirmed it is a lattice. If it fails for the single pair, then we are confirmed it is not a lattice. Also we have discussed lattices as an algebraic system, okay, in which it has to satisfy three properties. One is associative, second one is commutative, third one is absorption law. Okay, if one set is satisfied, all these three axioms means all these three properties means then the given set with respect to the relation like L comma less than or equal to there plus encircled plus and then star, or you can just change the position. This is called lattices as an algebraic system. Okay, so there also we are going to discuss in this class we can step into another classifications of the lattices, that is first lattice is called sublattice. Okay, sublattice. So here it's very simple, it's very simple. So here we can step into that. So here sublattice is called, it has to satisfy only one condition. Yeah, sorry for the delay. Okay, so here if suppose 1 minute. Okay, if one algebraic system satisfies the property closure property. Okay, if it satisfies, actually here you will be provided the set L in which you are going to pick a subset like S is a subset, you can consider like is a subset of L means if it satisfies the property closure property with respect to two operations, that operations are called, one is GLB operation, one more is LUB operation like A star B and then A plus B. Both should belong to S, not belong to L. Okay, listen carefully. There you might have the largest set, that is L, that is a lattice in which you are going to pick subsets like many subsets. So this may be S1, S2 or S3. Okay, in which there might be some elements A comma B comma C comma D comma whatever may be. For each and every pair of your S, if you apply the closure operation, that means closed relation with respect to two operations, one is GLB and then LUB, then it might have satisfied the property which should belongs to S. Okay, that means same set, subset. There you will be arrived on answers, right? That answers should lie inside the same subset itself, means then the subset is called sublattice. Have you understood this definition? Can we step into the examples related to that?
Can
Can
you
you?
this definition once again?
Yes, sure. See here, you will have one larger set. That set is called, already it is defined like a lattice. Okay, in which you are going to pick one subset. That subset you can consider like yes, in which if it is a sublattice means it should satisfy one condition. That condition is called closure condition, closure property. So closure property, what it says, there if you pick any ordered pair, if you pick any ordered pair into the subset, it should satisfy A star B and then A plus B. Whatever the answer you are arriving, that answer should lie same at your subset itself. Okay, then the subset is called sublattice. Have you understood now? Is it clear?
Yes, sir.
Okay, now we can enter into the examples related to that, then you will automatically understand. Okay, see here, it is provided lattice. Okay, the corresponding diagram also given, that is the Hazy diagram for that. See here, they are given the lattice as A1, A2, A3 up to A8. Okay, so they are defined the subsets like S1, S2, S3. Totally three subsets are there. So S1, so they are given like A1, A2, A4, A6. S2 like A3, A5, A7, A8. Last S3 as A1, A2, A4, A8, in which our task is assigned to check whether S1, S2, S3 are sublattices or not. Give your justifications. That is the question is asked. So there, initially already you are aware about the definition of sublattice. So I am going to check the sublattice whether it is a sublattice of or not for the S1. So that means what is the definition says? You need to check A1 star A2. So that means if you pick any ordered pair from the subset, you should have the answer. You should have the answer should lie inside the S1 itself. Okay. See here A1 A2 A1 star A2. What is the answer? A1 star A2. A1 star A2. Greatest lower bound, right? So in your
A1.
lower bound, greatest value. So lower bound means that means lower level in which greatest level value. So what will be the answer?
A2.
Very good. A2. Okay. A1 plus A2 least upper bound.
A1.
Very good. That's it. So see you can check A2 A1 lies inside the same subset A1 A2. Likewise, you need to check for A1 A4 A1 plus A4. What is the answer? A1, A4.
A4.
Very good. Next.
A1.
That's it. Okay. Likewise, A1, A6, A1 plus A6. Okay. So next A2, A4, A2, A6. So likewise, you need to check between every pair of the vertices. Okay. Here I need to say one shortcut to you. See here, whenever it is not a, it is a shortcut, you can easily explore the ideas. See, whenever if you take a adjacent vertices to check whether it has a LUB or GLB means certainly it will be have GLB and then LUB. At the same time, in any one of the element will be a GLB, one of the other element will be the LUB. That's it. See here, A1, A2. It might be any one of the element will be the answer. Here A2 will be the answer means in other case A1 will be the answer. If A4 will be the answer means other case A1. So what I need to conclude from this, if you pick adjacent vertices to check whether it has a LUB or GLB means it will be the it will have the GLB and then LUB of both the ends. Okay, one case one element will be the answer, another case another element will be the answer. So most of the Hazy diagrams it will be the applicable one. Okay, so likewise if you check between every pair of S1 means you can check you will be the answer, you should get the answer which lie inside the same set, same subset. So from which I can conclude S1 is a sublattice. S1 is sublattice. Here it is very important to check between A2 and then A4 because both are lies at both the opposite sides. Okay, it's your duty, you need to check. Likewise, A2 A6 it is not required to check. Sometimes it is enough to check, but it is required to check because it might have the other element which lies in the other subset also. Your duty, you need to check between every pair of the vertices of the subset, then you can confirm it is a sublattice or not. Have you understood the first example? Is it clear?
Yes, sir.
Yes.
Okay, now we can enter into check the second subset, that is S2. Okay, second subset. So here Likewise, S2 in your S2. Okay, already I've told you. Uh, Already I've verified S1 and then S2 are sublattices. S3 is not a sublattice. I will say the counter why it is not a sublattice later. Okay, now I can just try to show just one or two examples into that S2. Then immediately I can move on to the S3 example because that is very important in this because you will not. That means you will get confusion in that. Okay, so here I'm going to just to say one or two examples in S2, like picking a pair. Okay, in S2, we can pick the pairs like A3, A5, A7, A8, right? A3, A5, A7, and then A8. So there we can check between um, A3 and then A8. Okay, so we can just choose some complicated pairs. A3 star A8, then A3 plus A8. So can you just try to say the answer of A3 star A8?
A3.
Very good. That is also very easy, I think. Okay, A3 plus A8.
A8.
That's it. Okay. A3 star A8 GLB. Is it right?
I think it's reverse.
Very good. Correct. A8 and then A3. Because GLB, lower bound means A3 lower level actually will be A5, A6, A7, A8 in which only one element will be the lower bound element, that is A8. So certainly GLB here A8. So in your A3 plus A8
Considered
least
lower
upper. So that
with
is,
regards.
sorry.
Sir, if you consider it to be the cuboidal plane at the base, then A3, A5, A7, A8 are on the same level, right?
A3, sorry.
If you consider that to be a cuboidal shape and then A3, A5, A7, A8 can be at the lowest level, right?
No, no, no. I see here, this will be at level 1. This three
Understood.
elements,
Understood.
level 2. This is level 3. This is level 4. Now, have you understood?
Yes.
Is it clear? Okay, fine. Okay. So, according to that, so next, likewise, you can pick the other pairs also. You can check next A5, A7. A5 star A7 and then A5 plus A7. Can you try to say the answer? Star A7,
A8.
A8. You can check A8 lies inside the set. Yes, it is right. Next, A5 plus A7,
A3.
A3. Yes, A3 lies inside the subset S2. So likewise, you should check between the other pairs also. Okay, then it might be satisfy the property of sublattice. So S2 is also sublattice. Have you understood this S2 example? Is it clear?
Yes, sir.
Okay, now we can enter into the another one. So I'll say the answer here. S3 is not a sublattice. Okay, already I have verified. So from your side, I'm expecting the answer in a counter way, like in which pair it will not be it will not satisfy the sublattice condition. Can you just pick the exact pair? Otherwise, no problem. You can just choose some random pass. You can say your pass. I'll check in the board so that others also can try. No problem. So this will be A1, A2, and then A4. Next A8. So that's it. Totally four elements are there in your subset S3. We need to check 4C2 combinations, right? That means A1, A2, A1, A4, A1, A8. Likewise, A2, A4, A2, A8. Last one is A4, A8. So now you can just guess which pair will not attain the sublattice condition.
Sir, A to A4.
Very good, correct, exactly right. Okay, A to A4. Okay. A2 plus A4. Now, A2 A4, what is the answer? A2 star A4? GLB.
A6. A6.
A6.
6, which is
A6.
not in the set.
Very good. Which not lies inside the set in your S3. Okay, that means otherwise you can mention like which is not contained in S3. So here itself you can conclude the answer by providing only one counter example. That is more than enough. If it is a lattice means you are, if it is a sublattice mean you need to show at least three, or if depends on the count of how much it has, how many elements are there in the subset. Okay, if it is a lattice means you can just simply provide at least 2 or 3 pass in this, because totally 4 elements are there. No, if it is if it is not a sublattice means it is enough to show only one counter example. That is more than enough. Okay, so because of that condition, A6 does not lie inside the subset S3. I can simply close like S3 is not sublattice. Have you understood the concept of sublattice? Is it clear to you?
Yes, sir.
Okay.
Yes.
Before enter into another type of the lattice, you can just fill the attendance form and then we can come back. Please fill the attendance form soon. Okay. Okay. Okay, next definition is called complete lattice. It's a very simple definition. See here, you will have the lattice, right? There you will have the subsets, not a sublattice. You may have the multiple number of subsets like S1, S2, S3, S4. Here they didn't use the word.
Sharing the screen.
Oh, sorry. Okay. Now can you able to see the screen?
Yes.
Yes, sir.
Oh, fine. Okay, next definition is called complete lattice. It's a very simple definition. Okay, see here, you may have one lattice set, okay, in which it may have the multiple numbers of subsets. Here they didn't use the word sublattice, just you may have subsets S1, S2, S3, S4. Okay. Here what they are saying, the complete lattice definition means in your lattice you may have the numbers of subsets. Each of its subsets should have LUB and then GLB. LUB and then GLB. That means it should have the element. It should not be the empty set. Okay, in each of its subset, if you check between every pair of the vertices, it should not be the empty set. Okay, in such case, then the lattice is called not only a lattice, it is to also to be called complete lattice. Okay, complete lattice. So there you are able to split with respect to the given non-empty subsets. Each of its subsets, if you take a GLB and then LUB, it will not have the empty as the answer. Okay, so if it is so, then the lattice is called complete lattice. Have you understood this definition?
Yes, sir.
Okay, next. Next definition is called bounded lattice. Bounded lattice is already we are discussed anyway. See here, in which you can consider one example like that. Okay, so here okay, so you can just simply consider like 1, 2, 3, 4, or maybe 4, 2, 3, and then 14. Here 14 you can consider some numbers, random numbers. I'm just assigning here some random numbers to show the example. And then 5, 6, just 11 or whatever, maybe something. Okay, I didn't fix the relation, I didn't fix the proper set. I'm just to show the example I'm providing here. See here in this diagram, what is the greatest element? I'm just
14, sir.
with respect to levels only, you are supposed to say the answer. Already I've told
11,
you.
sir.
Okay, always it will not be fixed what relation you are applied here. With respect to the relation, you need to say the answer only on the basis of Hussey diagram. What will be the highermost level element? That will be the greatest element. Already we have discussed about that. Okay, so here this will be the greatest element. This will be the least element, right? Always these bound values, listen carefully, these bound values will be represented as this will be 1, this will be 1, this will be 0, this will be 0, this will be 1. So these bound values will be called as both the n values, also to be called like n values. This n will be represented as 0 in another way. This n value, top n value, will be assigned as 1. Okay, if one lattice set, when you draw this as a Hussey diagram, if it is having both the bound values, means then the lattice is called bounded lattice. Okay, now can you try to say which is a bounded lattice?
This is not a bounded lattice, sir.
Why? What is the reason?
Because it has two upper, like the
Very good.
top
Very good.
has
So
two.
here we could not fix which one can be the greatest element. Here we could not fix which one can be the least element. So since it is the reason, we could not predict 0 and then 1 for this lattice Hussey diagram. So we should not call this as a bounded lattice. But this is a bounded lattice because of the reason here I can able to determine 1 and then 0 values. Here 1 means the 11. That means greatest value always will be represented as 1. Least value always will be represented as 0. Okay. Have you understood this definition, bounded lattice definition? Is
Yes,
it
sir.
clear? Okay, now next. Next definition is actually called complement. Okay. How we can determine complement of one element? Okay, complement of an element. See here, you can consider one example. Yes, you can consider one example. Maybe 13, here 15, and then 17, 21. Okay, some numbers. So here always if I am going to determine complement of one element, means then it has to satisfy two conditions. What are all the conditions? That condition is called a star b equal to 0, a plus b equal to 1. Here can you just guess what it tries to say? A star b equal to 0, a plus b equal to 1. What it tries to say? Any guess?
The GLB should be the lowest level, and the LUB should
Very
be the
good.
highest level.
Very good. So GLB should be the greatest element. That means what about the Hussey diagram level, whatever may be, but you should get the final answer as your your lowermost value, that is 0. Okay. that means whatever maybe the level provided in your Hussey diagram, your A plus B should be the highermost value, that is your 1. So here can you just guess what is your 1 in this Hussey diagram?
21.
21, that's it. Okay, your 0 will be 13. So here I can pick the pass 15. Okay, so to find the 15 complement element, can you just guess what will be the identity element, sorry, complement element of 15?
17.
17.
Simple, very simple. Okay, 15 star 17, you will get the answer. You will get the answer
13.
13, that is our 0. Okay, next 15 plus 17, you will get the answer as 21, that is our 1. So it is satisfy the condition of the complement condition. So I can call complement of 15 is complement of 15 is 17. Likewise, next complement of 17 is
15.
15, that's it. So likewise you can check 21, complement of 21 will be 13, the complement of 13 will be 21. So this is the way to determine the complement. Okay, here I have given very simple example, but you should stick on to the definition of complement element, then only in your exam you can easily find what is the complement element of one vertices, whatever they are asked you to determine. Okay. Next. Okay, so here in this next definition, that is actually complemented lattice. Already you have discussed about the complement, how to determine the complement element of the Hussey diagram. Okay, so now we can step into the another definition, that is definition is called complemented lattice. Complemented lattice means in such case, you will not able to determine the complement element, right? So here what is the definition of complemented lattice means, if you if you are able to determine the complement element for every element which appeared in the given set, okay, then the given lattice is called complemented lattice. Okay, now can you just here this is your 1, this is our 0. Okay, now can you just according to this diagram, what is our complement element of 6?
1.
1. What is the complement element of 3?
2.
2. Okay, now so from which can I call this as a complemented lattice?
Yes, sir.
Okay, likewise I can step into the another example. Okay, in which what is the here our this is our 1, this is our 0 bound values, right? Okay, what is the complement element of 2?
5 and 3.
Okay, very good, very good. So 5 and
3 also, sir.
very good, super. 5 and 3, because see here you can just check the property 2 star 5, you will get the answer as 1. Okay, next 2 plus 5 will be your 30. Next it will attain the same answer when you check for 2 plus 3, sorry, 2 star 3 and then 2 plus 3, you will have the same answer. You can just check. Okay, so from which I can conclude the complement element of 2 is 3 and then 5. Likewise, the complement element of 3 is 2 and 5. Complement element of 5 is 2 and 3. So, but it follows the property. Okay, that is not a problem. Next, I can go with the next example. Uh, uh, what is the ordered pair will be there? Like 1 star 2. What is the answer? 1 star 2.
1.
1. Okay, next. 1 plus 2.
2, sir.
2. Will it provide the 0 in your 1 plus 2? Will it give the upper bound value? Sorry, the highermost bound value, that is your greatest element answer?
No, sir.
No, it is not providing. So from which, because of the reason it is not satisfying the complement condition, complemented lattice condition, I should not call this example as not I complemented lattice. So it is not a complemented lattice, but it is a complemented lattice. I could not able to determine here complement element of 1 and then 2, right? Okay, it is not satisfying. Between every pair, if you check, you should attain the answer both the bound values. If it is not so, then I can simply close the answer. It is not a complemented lattice. Have you
Sir,
understood this?
even in the first one, if you take like complement of 1 and 2, like you won't get the right thing, no, sir.
Yes, yes, yes. No, in your case, okay, 1 minute. Yeah, yeah, yeah. Okay, okay, okay. Actually, which every element has a complement. Here I am able to determine the complement of 1, right? So likewise, there will be some element which could not determine the complement. Can you just pick which element? I think I have taken a wrong example. Okay, here will it be possible to determine the complement element for each and every element?
Yes, sir.
Yes, so it's also complemented. Anyway, good. Okay, so likewise, so there might be some chances. So if you extend one more vertex, what will be there? Now, is it possible to, okay, now you can consider one more element, 45. You can keep the same diagram. Can I able to determine the complement element of 45?
It's 1, no, sir.
Is it right? Okay, anyway, you can just check in your Google, not complemented lattice definition, not complemented lattice examples. You will find some examples. So here I have picked the examples to satisfy the complemented lattice. Anyway, you can just check from your side. There will be the, you even in your GX website system, there are multiple numbers of examples are provided. You can just check. That's your duty. Okay, fine. But this is a definition of the complemented lattice. Next, we can enter into the last definition of this model, that is distributive lattice. Okay, distributive lattice. That's very simple. Already you are aware about the property of distributive. Here, same. Whenever distributive means in your associative, you will be applied between the three elements. Same notation should be applied. But in your distributive, there will be the different notations will come. That means two notations will come. Okay. So according to that, A star B plus C equal to A star B plus B A star C. So likewise, even if you change the positions of the notations, you should get. Okay. So if one lattice satisfies these two properties between, if you pick any triplets like A comma B comma C, likewise if you pick any three elements, if it satisfies these two conditions, then I can claim this lattice is called distributive lattice. Have you understood this definition? Is it clear?
Yes, sir.
Okay, here star comma plus represents GLB and then LUB respectively. That's it. Okay, here I'm not going to solve this problem. Simply I have just given the diagrams for the practice. It's your duty. You can just check whether these two lattices are distributive or not distributive. Anyway, here they are mentioned. Show that the lattices given by the diagram are not distributive. Okay, you can just pick respectively three elements counter example to show it is not a distributive by verifying that properties. Okay, that's it. So here straight away they are provided, this will be the upper value, this will be the lowest value. So likewise. Okay, so it's your duty, you should check whether these diagrams are representing this in what case, in what three elements it will not show the property of distributive. Have you understood this definition and then respective diagram for that? Is it clear? Is it clear? Can you able to complete this?
Yes, sir.
Okay, fine. Okay, actually with that, this model is over. So it's your duty. You can just do